To make a scatter plot for the data here, we'll open a larger version of it, and we need to place the points where they go. Rather than fighting to get it exactly at 3 and 40 with a mouse, I'll just place 1, 2, 3, 4, 5 points, since I have 5 XY pairs, and then select them and adjust them to where I need them to be with the coordinate entry. So first point 340, second point 735, third point 1530, third point 3027, fourth point 7518. So now I know that they are in the right place. I can move on. The correlation appears to be pretty strong and negative just from the graph. Now we can verify these values to calculate R, or we can use the calculator to calculate R. So I'd like to do that a little more efficient. I need to enter the data into the list. List 1 are the X values, that's 3, 7, 15, 30, and 75. In list 2, the Y values, 40, 35, 30, 27, and 18. So now I want to know about the relationship between these two, and I would calculate that in Calc. Linear regression, AX plus B, or perhaps you're used to looking at it as A plus BX. I believe that's the convention that this textbook uses. The X values are in list 1, the Y values are in list 2. I'd like to calculate the regression line. Looks like my stat diagnostic is not on, so I'll turn that on by opening the mode menu, scroll down to stat diagnostics, turn it on, and then run the regression again. Now I get the value for R and R squared, and I like that a little bit better. So here R to 3 decimal places is negative 0.948. 7 is the 3rd decimal place. Look next door to the 5. 5 makes the 7 round up. This is a negative value, so that would imply that Y will go down as X increases. So Y should decrease as X increases. That's what we saw in the scatter plot as well. X got bigger, Y got smaller. And then we are good to go. So the next question is the longer one. To draw the scatter diagram, that will look the same as the one we just did. And then you can find the sums here, verify them from before, find the mean of X and the mean of Y. Then we have to enter the actual least squared regression line and make the scatter diagram with the data, the raw data, and the least squared regression line. So let's go back up here and get this data for us in the list again. So 5.8, 6.1, 3.6, 5.2, 6.2, 6.5, 11.1. And the Y values are negative 1.3, negative 4.2, negative 7, negative 4, 3.6, negative 0.1, and negative 4.4. Then we can run the linear regression. So now I have R, R squared, A, and B, and here's the equation of the line. A, negative 3.3 plus B, 0.1344. So Y hat, the equation of the least squared regression line, A plus BX, A was negative 3.34, 0.41 to 3 decimal places, plus b 0.134 times x. So that's the equation of a line. A values, then the b value times x. And that matches this equation. If you run linear regression ax plus b, then you'll just enter that line. A, the number a will now switch to be 0.13, and then the b value would be negative 0.3. You can see that here if you calculate statistics again, but use the other version. Now a is 0.13, that's still the value of slope, still the number that gets multiplied by x, and b is negative 3.34. That gives the same equation of the line. The terms are just in a different order, and by the cumulative property of addition, we can add things together in any order we want. So it's exactly the same line, just a matter of formatting. So to draw the scatter diagram, pull my data back up. Now we have to do both things, the scatter diagram and the least squared regression line. So put in 1 point, change that point, make sure that it is where I want it to be, which is 5.8, and a y value of negative 1.3. So there's the 1 point, and we'd have to do that for all the points in the data set. So give me a moment and I'll put those in. Okay, so now I placed all the data points in to make the scatter plot, and now I need to plot the least squared regression line, negative 3.341 plus 0.134x. So this is a line, and the y-intercept is somewhere like negative 3.3 something, and the x, or the slope, is up 0.134 and over 1, but that's kind of not too sure. So I would just place it where it looks like it should go. And then look at stat2 variable statistics to find x bar and y bar. So x bar is 6.357. So if I use the pointer tool, I can say that this point should go through 6.537 for x, and then the y coordinate will be y bar on the calculator, negative 2.485. Or 86 to 3 decimal places. You can put in more if you want to be more accurate. And then I need my y-intercept. So if I put in 0 for x, the y-intercept is negative 3.34. I guessed that pretty good. I'm impressed. So there's the least squared regression line with x bar, y bar, and then the y-intercept there. So you can see that guy is supposed to fit the data. Now that he's plotted, we could find the value of r squared. Remember that kicked out when we ran linear regression. Either one, this one or the a plus bx, will still give r and r squared. R is 0.0885, and when you square that value, you'll get 0.0078. So that's r squared, 0.0078. R squared 3 decimal places, so 0.008. That means that there was only 0.8% of the deviation in y is explained by the least squared regression line, and the unexplained variation is 1 minus point, this should be 0.8 or 92. 0.8. Oh, excuse me, as a percentage, so 0.008 as a percent is 0.8, and we want 100% minus 0.8, so that's the 99.2% is unexplained. So that doesn't look like we have a very good model for prediction. You can kind of see that from the graph. So the correlation is so low that it doesn't make sense to use the least squared regression line in this case. Okay, so I hope that gives you a good understanding of how to plot those. Of course, if you have any more questions, just go ahead and send me an email or post to the discussion board.